Okay, so today's paper, it really it's got me thinking about, how often our best laid plans kind of go awry. It's called adaptive probabilistic planning for the uncertain and dynamic orienteering problem. And it's all about making decisions when you just can't predict everything.
It's like they took this classic computer science problem, the orienteering problem, like finding the most rewarding route, and then bam, they injected real world chaos.
Exactly. Yeah. The classic version is kind of like a treasure hunt, right? Find the best path, limited time, maximize your rewards. But this paper, it introduces, it's called the uncertain and dynamic orienteering problem, or UDOP. And suddenly everything's in flux. Travel times, rewards, costs, they're all unpredictable.
Imagine you're planning a road trip, right? And gas prices are going crazy, roads are randomly closing. Even the places you want to visit, they might just shut down for the day.
Yeah, no kidding. The paper actually uses this example of a UAV, an unmanned aerial vehicle, and it has to recharge the sensor nodes in a network. But with wind gusts, obstacles, the energy it takes to reach each node is constantly changing.
This is a huge GE deal because, see, most planning systems, they kind of assume you know all the probabilities beforehand. They're great at finding the optimal solution, but only, and this is key, only if everything goes exactly as planned.
And, well, we know that almost never happens.
Right. So these researchers, they developed a new approach. They call it ADPT. Stands for, get this, adaptive approach for probabilistic paths. So instead of being stuck with that initial plan, it learns, it adapts as it goes.
It's like having a super smart GPS. One that can reroute you around traffic jams and even suggest new places to stop based on, on your changing needs and all that.
Perfect analogy. ADPT basically works in 3 stages. First, you have the initial plan based on whatever information you've got, kind of like your regular GPS plotting a route. That's the offline planning phase.
Okay, got it. But then, as the UAV gets moving, that's when things get interesting, right? It starts encountering the real world.
Right, exactly.
So during the execution phase, ADP starts gathering all this real-time data, actual energy costs, obstacles, all of that.
And it's constantly comparing what it predicted to what's actually happening, using that feedback to learn. And that's where this thing called Bayesian inference comes in. It's a way of updating your beliefs based on new evidence.
Okay, so we've mentioned Bayesian inference a couple times. Can we break that down a bit? It sounds kind of, intimidating, to be honest.
Oh, it's actually pretty intuitive once you get it. Imagine a jar full of cookies, right? But you don't know how many are chocolate chip and how many are peanut butter. You start grabbing a few cookies at random and say most of them turn out to be chocolate chip.
So you start thinking, okay, this jar is probably mostly chocolate chip cookies.
Exactly, that's your initial belief. But then you keep pulling out more cookies, right? And maybe the ratio starts to change. You get a few peanut butter cookies in a row. So you adjust your belief, right? You're taking that new evidence into account.
So Bayesian inference is like constantly updating your assumptions.
Yeah.
Based on what you're seeing instead of just sticking to your initial guess.
Precisely. And that's what ADPT does so well. It starts with this, rough idea of how much energy things will cost. But it keeps refining that knowledge as it goes, encountering new stuff.
So by the time it gets to the online planning phase, it's already got a much better, more accurate model of the environment.
Exactly, yeah. ADPT uses that updated knowledge to replan the route. So it's optimizing for the current conditions, not just the conditions it thought it would see.
And this approach, it was incredibly effective, wasn't it? They ran simulations, all sorts of crazy, unpredictable environments, and ADPT, it just nailed it every time. 100% mission success rate.
And not just finishing the mission either, it was also good at balancing risk and reward, took into account different safety levels, making sure that UAV always had enough energy to get back home, even with all the challenges.
ADPT sounds amazing. But I imagine there's some limitations, right?
Of course, no algorithm is perfect.
Right.
One of the biggest challenges with ADPT is, the computational cost.
Well,
Bayesian inference, it can be computationally expensive, especially when you're dealing with complex data and in real time, too.
So, okay, it works great in simulations, but scaling it up to real-world applications, that could be a problem.
Exactly. You're always balancing the accuracy of the model against the time it takes to actually compute those updates. So for something like autonomous driving, where decisions need to be made super fast, the computational demands of ADPT might be a bit too much.
Makes sense. It's like, I don't know, trying to run some crazy complex weather simulation on your phone. It might work eventually, but it's going to take forever and kill your battery.
Exactly. And another thing, ADPT needs some initial information about the environment to work, at least a starting point, like a basic understanding of the possible states and transitions.
So if you were like dropping ADPT into a completely unknown environment, no prior data at all, it wouldn't do so well.
It would definitely struggle, yeah.
Okay.
In those cases, you might need to like combine ADPT with other types of algorithms,
Yeah.
something that could gather some initial data, build a sort of preliminary model of the environment.
So it's like trying to navigate a new city without a map, I guess.
Yeah,
You might figure it out eventually, but
yeah,
having some idea of the layout beforehand would definitely help.
exactly. And it's important to remember that ADPT, well, any machine learning algorithm, really, it's only as good as the data it's trained on. So if the data is biased or incomplete, well, the model's predictions and decisions, they're going to reflect that.
Right, so in our UAV example,
Mm-hmm.
if the training data only included flights in, like, perfectly calm conditions,
Yeah.
then a sudden wind gust could really throw it off.
Exactly. You need to train these models on data that captures, the full range of possibilities.
Speaking of possibilities, this research has me thinking about all sorts of applications for ADAPT, beyond just, UAVs. So it's time for Novel Notions, where we brainstorm some wild ideas, outside-the-box stuff, inspired by ADAPT, of course.
I always love this part.
Me too.
All right, let's see what we can come up with.
Okay, so what if we took ADAPT out of the skies and put it into, I don't know, the financial markets?
Oh, interesting.
Like imagine an AI-powered trading system that uses ADAPT's principles to, navigate the crazy ups and downs of stocks and bonds.
So instead of optimizing a flight path, it's optimizing a portfolio, right?
Yeah.
Constantly adjusting its holdings based on real-time market data, economic indicators, all that.
Yeah. You'll be like having this financial advisor,
Sure.
one who can react instantly to, breaking news, the economic reports, even social media sentiment, making trades like in the blink of an eye to maximize gains, minimize losses.
And just like ADIPT considers those different safety levels for the UAV, our stock market AI could have like different risk tolerances, adjusting its strategies based on, how much risk the investor is comfortable with.
Exactly. Yeah. You could even have a system that personalizes those investment strategies
Yeah.
based on like an individual's financial goals, their time horizon.
Yeah.
And it would be constantly adapting, to their changing needs and all that.
That would be huge for the investment world. But why stop there? What about healthcare?
Oh, now you're talking.
Imagine a system that could personalize treatment plans for, say, patients with chronic illnesses, constantly adjusting medications, therapies, all based on real-time data, from wearable sensors, medical records, all that.
Wow.
It could monitor vital signs, blood sugar levels, activity levels, even sleep patterns, and make these like micro adjustments to the treatment plan to optimize for each patient's individual needs and responses.
It would be like having a doctor who's with you 24/7, constantly monitoring your health and making these tiny tweaks to your care plan to keep you as healthy as possible.
And think about the potential for preventive care. A system that could identify those early warning signs of a potential health issue and then, proactively recommend lifestyle changes or even medical interventions before the problem even becomes serious.
Like a personal health coach almost.
Yeah.
Guiding you towards a healthier future.
Exactly. Of course, these are just novel notions, right? Just ideas to get people thinking.
Yeah, but the potential of ADAPT to revolutionize so many different fields, it's incredible.
There really is.
It's about more than just optimizing routes or maximizing profits, It's about building systems that can thrive in complexity, adapt to uncertainty, and ultimately help us make better decisions in a world that's constantly changing. It's really amazing to think about how something, developed for drone flights could have such a big impact on so many other areas.
It really shows how powerful it can be to think outside the box. We tend to get stuck in our own little worlds, our own fields, but sometimes the best solutions come from borrowing ideas from places you wouldn't expect.
Like cross-pollinating ideas to create something totally new.
Exactly. And that's what's so exciting about this ADPT research. It's not just a technical achievement. It's like a whole new way of thinking about how we build systems for a world that's always changing, always uncertain.
Yeah, it's like we're moving away from those rigid, pre-programmed systems and towards systems that can actually learn and adapt.
Yeah.
And even improvise in a way.
It's almost like, I don't know, giving machines a little bit of human intuition.
I like that.
We're not trying to replace human intelligence, obviously.
Yeah.
But we can augment it,
Mhm.
by creating machines that can handle the the routine stuff, the predictable things, so we can focus on the creative stuff, the strategic thinking, the things that humans are really good at.
Right. It makes me think about how we approach, planning in our own lives. We all have goals, plans, but the people who are really successful, they're the ones who can adapt when things change, when things don't go according to plan.
Absolutely. Life is rarely a straight line, right? It's full of detours, roadblocks, and unexpected opportunities too. So being able to adapt, to adjust our course, that's essential for navigating all of that.
So this research on ADPT, it's not just about building smarter machines. It's about building systems that reflect something fundamental about being human, the need to embrace uncertainty, and the power of adaptation.
And that's a really powerful message for all of us, whether we're designing algorithms, building businesses, or just, living our lives.
It's a reminder that being flexible, being resilient, being willing to learn and adapt, those are the keys to success, no matter what you're doing.
So next time you're facing a challenge or things don't go as planned, remember ADPT. Embrace the uncertainty, gather new information, and adjust your course. You never know where it might lead you.
That's a great point to end on. Thanks for joining me on this deep dive into the world of adaptive probabilistic planning. I hope you found it as thought-provoking as I did.
It was great exploring these ideas with you.
And for our listeners, be sure to check the show notes for a link to the paper and some other resources too. Until next time, keep your minds open, stay curious, and keep your plans adaptable.